upside down. Cool. Hi, my name's Ben, and I work as a software engineer at Tweak. And today I want to tell you about Skyscope, which is a new tool that I've been working on. And Skyscope lets you visualize and explore Bazel Skyframe graphs in your web browser. As to why you'd want to do this, maybe if you're debugging a tricky dependency issue, or you find yourself working in a new repository and you want to quickly gain an understanding of how it's structured, and which targets depend on each other, then it's quite useful to be able to see a visual representation of the build graph. So this is what it looks like. I'm going to show a video demo in a few minutes, but here's a preview first. So one way to characterize Skyscope is to say that it's an interactive front end to Graphviz. So I'm sure many of you are familiar with Graphviz, but if you're not, the basic idea is pretty simple. Instead of manually drawing out your graph in some diagram software, you describe its structure in a domain-specific language like this. So this example describes a graph with 5 nodes, A to E, and various edges. And then you run this through Graphviz, and it produces an image like the one on the right. So Graphviz has been around for a long time now, 20 years at least, and many different tools and libraries support it, including Bazel. So this post tells you how you can visualize your build graphs with Bazel. But the basic idea is that when you do a Bazel query, you can get to output in Graphviz format. And then when you run that through Graphviz, you'll get an image like this. So this one's taken from the Envoy repository. And that's pretty useful. Here's an example of a larger graph. You can't really read it at this scale, but if you zoomed in, it is legible. There's some crossover with the edges, but it's not too bad. The trouble is, as your graphs start getting larger and larger and more complex, the edges quickly become a tangled mess until it's basically impossible to make any sense of it all. So that's Graphviz. It's a great tool, but it does struggle with large graphs. And that's not really the fault of Graphviz. It's just that laying out graphs in 2D is inherently difficult. So pivoting now to Skyframe. I don't think I have to say much about this. We had a great talk this morning on Skyframe. So I guess I'll just say that Bazel lets you get access to the current state of the Skyframe graph with the Bazel dump command like this. And just to show you what that looks like, this is a very small snippet of what could potentially be hundreds of megabytes or even gigabytes of data of text. This isn't meant to make any sense to you really, but I'll just say it represents 5 nodes. 5 nodes with 4 edges in the graph. There's about 40 different types of nodes in a Skyframe graph, and they all correspond to the kind of things that Bazel needs to know about to do incremental builds. So yeah, it's great that we get access to this, but it's pretty hard to make any sense of. It'd be great if we could parse it and feed it through Graphviz and get a visual representation. But as I said, Skyframe graphs are huge, and there's no way that Graphviz is going to handle that much data. So the solution I came up with for Skyscope, it's fairly obvious, I guess. Instead of trying to render the entire thing, just render a tiny subset, say maybe 10 to 20 nodes at a time. And at that scale, Graphviz will work much better. It'll be fast, and the graphs it produces will be understandable. The key thing is, though, that the rendered graph is interactive, so you can click on various parts of it to show and hide nodes. And yeah, that's basically the idea behind it. Just before we come on to the video, a note about terminology. So Skyscope has this concept of expanded and collapsed nodes. When a node is expanded, you get to see all of its edges. The trouble is, some nodes might have hundreds or thousands of edges. And so that's going to, even if you just have that one node visible, it's going to make a mess of the graph. So you can collapse nodes, and then only edges to other visible nodes are actually shown. So yeah, here's the video demo. The first thing you need to do is import the current state of the Skyframe graph into Skyscope. The Skyframe graph can get pretty huge, so it's usually a good idea to start with a Bazel shutdown. That clears the graph, and then you run the build command to populate the graph again with just the nodes that you're interested in. So here I'm building the Bazel binary itself. It was built before, so this is just going to, once it finishes loading and analyzing and checking the cached actions, it'll be done in another few seconds. And then when that finishes, you run a Skyscope import command, and that will dump the Skyframe data, parse it, and bring it into Skyscope. So just another few seconds, I think. Yeah, there we go. You can So Skyscope import on its own is enough, but you can optionally pass query and a-query parameters to it. And if you do this, then Skyscope is able to import extra context for targets and actions, and that gives you a richer experience in Skyscope. So the extra context is stuff like which build file the target was defined in, or for action execution nodes, you get to see a nice, pretty mnemonic label instead of just action execution. It takes about a minute to import this on my laptop, but I've actually cut the video here. So there's 400,000 edges. You'll see it jump up. There we go. So this is finished now, and you get a link to open in your browser. When you first open it, no nodes are visible, so it's empty, but you can search for nodes to display in the top here. You can search by file name or label, basically anything that forms part of the Sky key, the key for the node. So here I've searched for the Bazel server Java binary target and made it visible. When it's initially visible, so if you hover over it, you can see which build file it's defined in. It's initially collapsed, so you don't see any edges, but by clicking on it, you can toggle it to be expanded. So now you see all the things that depend on it and that it depends on. If you hover over these, you can see their action executions. By clicking on one of these hidden nodes, it makes that node visible in the collapsed state. And so I'm going to click on this. Yeah, if you hover over it, you'll see the A query output. By clicking on that, it becomes expanded. And then if you click on an expanded node, that collapses it again. So another feature to show you, I'm searching for a source file that I know the Bazel server target depends upon, cpp compile action.java. If I make the configure target for that visible, Skyscope knows there's a dependency there, so it will show you a dotted path between. And if you click on open, so yeah, that says there's two. If you click on open now, it'll make all the nodes on the dependency path visible. So this is kind of like a sum path query, I think is what it's called. So yeah, if you hover over this, you can now see how the dependency works. We've got the Bazel server binary depends on the main library, which depends on the rules library, which depends on the CPP library, which depends on the file. You can hold shift and make a selection of nodes to crop the selection to that. So you can sort of zoom in on an area again. Double clicking on a node makes all of its neighbors visible. So we now see that 4 other targets depend on this source file, 2 file groups and 2 Java libraries. I think they're actually the same label, but different configurations or something. Just to demonstrate the crop to selection feature again, holding shift and clicking these 3 nodes, that will focus in on those. Some nodes have hundreds of edges, like this one. So you might click that, and even though there's not many nodes visible, it still kind of blows the graph up a bit. But Skyscope has fully integrated browser history, so you should feel free to explore, because if you get lost or make a mess, you can always go back and undo stuff. Forwards works as well, so I think in a minute I stop going backwards and start going forwards. Nearly at time now, but I think there's one more feature to show. Yeah, so we're back to here. So making this hidden node visible, this is Starlight built-ins. Every target in the graph depends on this particular node. So yeah, I click it to try and expand it, and we're going to be here a while if we actually wait for this, because I've never waited to see how long it takes to render. But if you get in this stage, you can click the spinning hourglass in the lower right-hand corner, and that interrupts rendering and takes you back to the state you were in before. So yeah, I think that's pretty much everything I had to show you. Yeah, so thanks for listening, and please do.